I'm your friend. Okay. I try to be so nice. You just see what I get.
All right, so all right, so somebody say 61. 61's a good question. So the question looks like this, I think. Between what interval to what interval? 1 to 9. Min, did you do homework?
Yeah.
Oh, I wasn't even looking at the question. That's
Sound kind of sus.
I did it.
You did?
I didn't do it.
All right, so this is one of the question. Ethan, you gotta pay attention. If you got a right answer, it's 1/2. Anybody got 1/2 or did not get 1/2? Anybody did not get 1/2? Okay, so let's check it out. Usually u is inside a parenthesis. Now I'm gonna rewrite that 1 plus x to the 1/2, and I'm gonna say du is equal to what? 1/2 x to the negative 1/2 dx. Now this one is going to be 1 over 2 square root x dx du. I'm going to solve for dx, so it'll be 2 square root x du equal to dx. Now, this is a definite integral, so I'm going to draw the upper bound and lower bound because this is the x value. Ethan, that's the x value. So I'm going to change in terms of u world. I don't want to do it in x world. I'm going to do it in u world because it'll be save me one step. So that's going to be 1 plus square root of 9 is equal to 4. 1 plus square root of 1 is equal to 2. So that is the only thing that you need to learn how to do, Ethan. Okay. So that's going to be 4 to 2. And this one's going to be 1 over u squared, square root x, and then 2 square root x du. Now what happened is you do see this cancel out. It's going to be 2 to the 4, 1 over u squared du. It's going to be integration from 2 to 4, u to the negative 2 du, because you cannot take integral when they have denominator. U to the negative 1 to the negative 2 between 4 to 2. Negative 2 is going to be 4 to the negative 1 minus 2 to the negative 1. What's 4 to the negative 1? 1/4 minus 1/2 equal to negative 2 times negative half. Negative 1/4, I think. And that's equal to 1/2. So the answer is 1/2.
And where do you get the 2 root x du from? That's just from taking the derivative of u?
Yeah.
Okay.
Okay.
And that's off of dx, yeah.
Right. Put it in normal.
RV, do you do homework?
Yeah, and then you do. Okay.
Huh? 63 depends. What kind of question is it? Let me look at it. Yeah. 63 is a definite integral. 68. Oh, that's a good question. I'll read the 68 here. I said u equal to 2x just because I know how to take integration of cosecant, cotangent. That's going to be negative cosecant. I didn't do 62 yet, but let me go over 68. And this is the work I have. Do you understand? Let me know if you don't understand. Make sure you understand it. You guys are taking picture. That means you don't understand. You rather take a picture, not understanding it. So ask questions.
So you have of u equals 2x.
Are you sure you're in it?
Supposedly.
My handwriting's all.
I think I did it again. It should be like 13 or
Cool.
I did it once.
Charlie does write very well. Amio. Amio's cursive.
It's too much. I don't know how to write cursive. Then we just stop. For a while, it's so pointless. What's the point of writing cursive?
It was more efficient. It is more efficient.
You get a 2x cotangent of 2x, right?
Huh?
Cosecant 2x, cotangent 2x, right?
Yeah, I said u equal to 2x. Du equal to dx because
I
I
didn't see that you already. I'm an idiot. I was like, oh, what?
Okay.
Yeah,
Why you guys?
well, I ripped out like the first one.
You apply this one.
I'm regular.
Alright. Anyway.
Chris got in the FSU?
Yeah.
I'm sorry.
No.
Who?
I meant Bradford. You never.
Yeah, he's the.
No. I think my thing is, I feel like for people who've been deferred, pretty 50-50.
But I think they are deferred because they are too good a candidate. They probably know that they're not gonna go there.
It's overqualified.
No, but I'm saying it's like I'm thinking they want to compare against like a larger pool of candidates. So that makes sense. You're giving
No, that's like.
because like also why would you look at all your really competitive candidates now that you're like it gets an unfair because like it makes sense if a smaller pool of like candidates who are less competitive should get it now as opposed to being in regular.
More likely he's not gonna go there.
Does that make sense? It's maybe like
I don't even
a little guide to put up against.
No, but that's he's in Mac.
So Mac DeLong?
Mac.
Oh, Mac.
Yeah, exactly. That's why I said
I mean, he's in the band too. And like Jake Hill was in the like he's in the band of FSU. He's one of the players.
Right?
TJ.
Yeah, that's
Oh my
Is that the only school you
People
play?
learning about different.
How about USF? Did you get USF?
Why do you need to get
Did you get in there?
Yeah, okay, so where you
Just go there.
So
It's not a bad school. It's a good school. UCF would be closer.
I'm not trying to be
And when you say that, you don't have no money to buy food, you don't want to go back to your house and ask your mom. Gonna have.
Yeah,
Your
remember.
mom's nice. All right. Next question.
Is the antiderivative of these two, and since negative comes
Any other question you want me to go over before I go to the next one?
does that make sense?
hold on.
High school grad.
This is oh, so the antiderivative.
And next question.
So cosecant equals negative cosecant cotangent.
Don't do that.
Yeah, Mr. J.
So
Okay, that's what I want. That's what
Split the integral. How do you want us to
you
do
should
you
get
have
an
to
answer.
distribute the outside ones?
I know what you're talking about. Next question. Shh. You got any more question or no? No? I'll show you those other question that we went over on other periods. This is one of them is 1209 over 28. That was an interesting one. It's just a really ugly fraction. And this is the work. Oh,
That's gonna be.
I do not like that.
I think it was 65.
also, shh. Also, this one, there's something that's similar to the homework. I don't know if you just have exact question like this. Do you have exact question like this one?
Yeah, it's 63.
63?
62.
62, and that's the work. Is it exactly the same? Exact same number?
Yeah, it should be 60.
Okay, so this is the work, 16/3. So you not only have to use substitution, you have to split at one point, take out 1/4, split that part. This is a kind of difficult, but yeah, this is one of the harder questions in there. If you can do this one, you're doing great. Did you guys got this one? Anybody got this one? Raise your hand.
Can you zoom in on the work?
I cannot zoom anymore. That's all it was.
I don't know.
Why did your
Take a picture of it.
turquoise thing come out as lime green?
It's so hard to look on my phone.
Lime
And then
green.
Can you take a screenshot?
click this.
It's easier to take a photo here
It's
because
about
then
a
it's always
choice.
there.
It's also dry.
Oh, and oh, you're a maggot. Thanks.
I'm not gonna.
Oh my goodness. Yeah. Now I'm live stream. Now you are in the frame. Yeah.
I can read.
See, now you're in the frame.
Thank you, Elaine. Your friend the team.
No, I'm not moving back. Now you want to be in there.
It kind of looks like a knot. It looks. Your friendship means nothing to me.
Okay, so this is 62, I believe. You guys need to know how to do all the definite integral. I'm gonna penalize you a lot if you don't know how to do it. I promise you. It will be penalized if you don't know how to add fraction, subtract fraction, divide fraction, multiply, factoring out a constant, split. You gotta be able to use substitution, change the U-bound. You had to do all nine part of the world. So you had to be able to precise calculate your integrals. True. Know how you feel.
I'm assuming. Wait, I don't know what else. What?
That's the nicest thing I've ever said. This is why it means everybody.
If you need to take a picture of it. You need to know how to do it, and I will do it again when you get home. And just make sure you can know how to do it right. Jack, you didn't know how to do it? Did you finish your homework? That's only like a 63. You only did one question?
No.
I'm gonna tell your girlfriend to dump you.
Elaine's in awe of how good my camera is.
She's. Have you never seen it?
Dude, how is the blue so black? My is black.
It's just the difference between Android and Apple.
Well, it's also, no, she's saying visibly her eyes.
Alright, so this is the one of the question of a use substitution question on the multiple choice MCQ. Very difficult one. Very difficult one. I want you to try it and let's see if you got an answer. You got 2 minutes to get the right answer. So 10:34.
It's me, bro.
Oh, interesting.
Oh, right. Statistically, is 20% chance.
Good job. You can do math.
Sure.
Is that negative 5?
Wait, is it no?
Positive.
Oh, it's 5.
2 to 5. No, they didn't want you to take an integral. They just want you to, hey, can you?
Oh,
They just want you to write out the integral, everything in terms of u. Now that's why I say you gotta do your work in terms of u, not x. Don't ever come back to x. Once you stay with u, just go finish with the u. Change your boundary, change everything to u. You guys still got 1 more minute left. You gotta tell me your answer.
No.
Oh no. I have no idea what's in. You got 20% of chance to get it right. 30-second left. Got thumbs up. Anybody got an answer?
That was not 30 seconds. 30 seconds.
30 seconds. Time's up.
30 seconds left. All right, done.
All right, what's the answer?
It's B.
It's not
Wait,
B.
It's B. It's B.
I think it's
Wait,
B.
what's the difference between B and
Either B, D, or
oh,
B has the
B,
yeah.
B, B. Sorry, I should do that.
Oh, I'm an idiot.
Oh, then it's B. Yeah.
The answer is not B.
Okay. B.
It's C. 20% not working in my favor, bro.
The answer is E.
Okay.
That was the my second answer.
It had to be because it had to be 1 to 2.
All right, shh. First answer you should eliminate.
Because it has 5 and 2.
A and D is automatic gone because you use substitution. Change the boundary. X minus 1, like I said, change the bound. 5 is equal to 2. Right? And this is 2 to minus 1 is equal to 1. So integration between 1 to 2. Good. And on the bottom, on the top, it's going to be u. I already did that. On the bottom is going to be x and dx. Then you say, okay, that's x. What is x? X is equal to back sub. So u squared equal to x minus 1. X equal to u squared minus 1. So that's 1 to 2. That's what? U. And this one's u squared minus 1. The problem is dx. Because the dx is not in terms of u yet. Guess what? No. You're going to take a derivative. Instead of take a derivative here, we're going to take a derivative here. Oh, actually, take a derivative here. So that's going to be taking derivative of u squared equal to x minus 1. Because if I take a d to the dx, it's going to be 2u du is equal to dx. So dx going to be 2u du. So it'll be 2u squared over u squared. Oh, this is u squared plus 1, right? U squared plus 1 plus 1 plus 1 plus 1 du between 1 to 2. And the answer is this one, E. Nobody got it right?
I would have been two, right?
No, you won.
No, because
No,
I
you
put
won.
DX, so EU, and then I didn't finish the problem. It said 30 seconds, so I put closest thing I had. But if you look at my work, it's what? I don't know why I didn't finish the problem.
All right, got it?
Yes.
Okay, let's talk about Riemann approximation. How much time I have? Count Giuseppe.
Did we actually 24? Yeah, 24. Wow. 24.
24 minutes?
That's like, yeah, it's gonna be like one of our longest lessons.
Yeah. All right. We're going to talk about Riemann approximation. So it starts with, you can approximate the area under the curve, definite integral. So before, when we take an integration, when we take a definite integral not invented before, but the problem existed, was area under the curve. But, so Riemann says, well, I don't know how to take an integral yet, but I can brute force my way through. What do you mean by brute force? I can just break to 4 parts, break to 8 parts, break to 16 parts. I find out the rectangle of each individual rectangles, and I can find the approximation of the integral. And Newton come into play later, says, well, how about we break to infinite amount of pieces and approach infinity? That's why there was a definition of integrals if n approach infinite. And then you can calculate exactly area under the graph, which is known as integral. But the precursor is going to be a Riemann sum. There is 2 types. There's actually 4 types. I'm going to show you all the 4 types here. This is a function, and between 1 to 4, I'm going to break up to 4 sections. And this is called a left-hand approximation. It's based on the rightmost endpoints. And this looks like this. This left-hand Riemann sum is under approximation. You can see the right end is over approximation. Do you see that? Do you also see midpoint? Kind of like there's some over, some under, some over, some under. They kind of make up each other. So it's actually a very good approximation. The most precise one, I think, is the trapezoid. Why is a trapezoid? Did you see a trapezoid?
Yeah.
And this only have a small deviation. So trapezoid is very good rule. I will say of all the things, trapezoid and the midpoint, they are pretty close. I will say trapezoid will be slightly, in majority case, a more better approximation than midpoint, but it's very hard to differentiate because sometimes it depends on what's the function, right? So let's talk about that.
So
you can break the infinite amount of pieces. There's 250 pieces. See that? And this is 250 pieces. Well, it kind of froze. It's kind of froze, but anyway. So we're going to talk about a function. And we're just going to talk about simple function. So this function we're going to know as y is equal to 4 to the x. Between 0 to 2, and we're going to talk about 4 different type of approximations with a 4 sub interval, and not any type of interval. They are equal interval. So they are equal interval. They exactly same size on the width. The height is different, but the width is exactly same size. Now, what happened is, first part, I'm going to use the Riemann sum with the 4 subintervals. Okay, 4 subintervals. Actually, I'm going to write down 4 equal subinterval. 4 equal subinterval. So this is the first type of approximation. Second type of approximation is this. It's same exact thing. And I'm going to copy. I'm going to paste right here. And this one is going to be style. It's going to be blue. So that's B. Okay, so we're going to use right and this one is going to be left. It's going to be left. And you say, okay, well, write Riemann sum 4 sub equal interval, and we're going to try it. Now, I'm going to show you a couple of tricks that I always do. So I'm going to start with this. First trick. I'm going to go 1/2, 1, 3/2, and 2. And each one's going to be 2, 4, 6, 8, 10, 12, 14, and 16. And what I'm going to do is I'm going to use a table. So a table here is going to represent x and y. I'm gonna plug in the value. Now, why do I use the scale of 1/2, 1, 3/2, and 2? Here's the way to calculate each width of rectangle. Here's how to calculate it. It's b minus a over n. What is the b?
B is the largest value.
Which is what?
2.
What is a?
The lowest value, which is 0.
And what is n?
The number of segments, which is 4.
4. So that's gonna be 1/2. b minus a over n is to figure out each width over things. Huh? N is 4 because I have 4 sub-intervals here. Right? So I'm going to do it in terms of 4 sub-interval, and I'm going to start with a 0, 1/2, 1, and 3/2, and 2. I'm going to plug in to get values. What's 4 to the 0 power is? 1. What's 4 to the 1/2 power is?
2.
What is 4 to the 1 power is? 4 to the 3/2 power is?
Root of 8, right? Is it square root of 8? No. No, it's 8. It's alright.
Oh, wait. That's 13, yeah.
16. Okay, so then we're gonna use right Riemann sum. Now, remember, if I have 5 trees in a row, like I plant 5 different trees in a straight line, how many space between trees?
4.
4 space, because always 5 minus 1 is equal to 4 space. Does that make sense? If I have 5 trees in a straight line, there was space, there's only 4 space. So you can only use 4 of this value. Which value I'm gonna use? I'm gonna use 16, 8, 4, and 2. I'm gonna omit the 0 because I use right for most points. Does that make sense? Okay, so then all you gotta do is figure out each width, each rectangle. So here's a trick I will show you. I always tell students, plug in a point. This one is gonna give you 1 and write down 1 next to it. Write down the y value because you know which value I'm using. Very important tactic. 1/2. 4 to the 1/2 is 2. And write down 2 right next to it. That y value, you're gonna use it. 1. I'm gonna use 4. Write it next to it. 8. Write a number next to it. 2 is gonna be 16. Write a number next to it. Are you following me? Min, you kind of zone out?
No, I'm here.
Okay. So I'm gonna approximate this. What do you think? That's over or under approximation? This is over or under? If I use right Riemann sum.
Under.
Over.
Over. Yeah. Okay.
Under, over, Christmas tree. Are you sure?
Is it going up?
You're gonna bet your life on that? It's over or under?
Yeah, over because
Oh, geez, you're right.
If it's going down.
Okay. Now, oops. Oh, Now this is the right Riemann sum. And this is the graph. Right? So it's over approximation because the function's increasing. If I use right Riemann sum and function's increasing, that's going to be over. When they ask you, are they over or underestimation, you're going to say, are they increasing or decreasing? As far as right and left Riemann sum. If it's a right Riemann sum and function's going up, guess what? You're going to use rightmost endpoint, and rightmost is the highest value. Then you are going to get over approximation. Now, how do I approximation this? So this area is equal to, or estimation, is equal to 1/2, which is this is 1/2. The height is going to be 16 because I use this one. Plus 1/2 times 8. Plus 1/2 times what? Plus 1/2 times what? Do I use 1? No, because that's not relevant. I use 4 rightmost points. So those are the value I use for right And this one I omit. That means I ignore it. And then I can equal to 16 plus 8 plus 4 plus 2. And this will eventually equal to, I believe, 30 over 2. And which is 15. And this over approximation is going to give me 15. Now, if I do it in terms of 8, I'm going to be a little bit more precise than 4 rectangles. But I'm going to use 4 right now because your homework is going to be list how many are they. Now, 4 left Riemann sum. What I will do is I'm going to paste exact same graph here. 4 left Riemann sum. Are they over or under? Under. Do you see it? If you graph it in your head, it's underneath. So let's look at here. Are they under? Do you see that? Compared to the last one is way over. Can you figure out the approximation of this? Did you find the approximation? B minus A over N, which is 4. So it'll be 2 minus 0 over 4, 1/2 still. Which value I'm using? Min, come back to me. Which value I'm using? Huh? For the left Riemann sum. 4 leftmost, which is what? 1. And that's a width, right? This is the width. This is the height, right? So 1/2 times what? 2. 1/2 times what? 1/2 times what? So it'll be 1/2 times 1 plus 2 plus 4 plus 8. That's equal to 15 over 2. That's equal to 7.5. Guess what? This and this is way under, this is way over. You can average of them. We're going to talk about what's an average of them. This is actually a...
Would the average of them be the trapezoid? Because it's like a, because it's like the two bases?
No, Ethan, you are absolutely right. You're a genius.
Oh.
It's a trapezoid. And I didn't know this until last year. I talked to competition kids, competition from Boone's High School. The coach told me, he says, yeah, there's a trick to figure out. If you got left Riemann sum, you got right Riemann sum. If you average both, it's going to be a trapezoid. And I didn't know that until the things. Competitions. Ethan, you want to join math competition?
I would, but I'm really busy. I have stuff.
Yeah. Davis over year. I see how you are. Okay. Whatever. I just got my feeling hurts, Ethan. You have the brain for math competition, actually.
Well, thank you.
Because nobody figured out left plus right is a trapezoid. The average of left plus right is trapezoid. Very nice. Okay, let's do C. C, I'm not gonna use right or left. Besides right or left, what else I can use? Midpoint, good. So it's a midpoint. But midpoint, I cannot use 4 because I don't have 4 midpoints. So then midpoint, I'm going to use 2 equal subinterval. So midpoint, I'm going to use 2 subintervals. I'm going to paste this. I'm going to use the midpoint. And I only have 2, right? If I have a 2 here, what does that mean? That means I can use that formula. B minus A over N. What is B in here? What's B in here? What's B in here? Any day now. What's B in here? What is it? What is a B? 2. Good. This is a B. This is the A. Y'all are geniuses. 2 minus 0 over, well, we say have 2 subintervals, so that's 2. So that means each rectangle is going to have width of 1. Because I cannot do 4, I don't have the value right in between. So that's kind of hard. So what we're going to do is we're going to use the midpoint. The midpoint's interesting because midpoint here, I'm going to say, well, I'm going to use middle of this point. Throw it out. I was hoping that over and under is going to cover each other. And it's not really over, it's not really under. You're hoping for this area will go to here, this area to here. It can cover each other out. And that's good. So anyway, I have the width is what? One rectangle is what?
1.
1. And this is 1. So I'm going to use 1 times 2 because I base on the 2. That's why I draw the value there. And I draw the 8 there. Plus 1 times 8, that's equal to 10. So 1 is 15. 1 is 7.5. This one's 10.
So you base it off of 8 and 2? You don't base it off of the midpoint?
I do use 8 and 2 is because that's the middle of 0 and 1 and 1 and 2. Because that's why I draw it. This is how I draw it. If you understand the drawing, you understand how to get that one. I only have 1 minute. I'm going to do a trapezoid rule. So D is going to be trapezoid rule. And trapezoid rule is going to be same thing. I'm going to paste this, but I'm going to draw a trapezoid according to it. So I'm going to use 4 subinterval again. 4 subinterval. And I'm going to use 4 subinterval. So I'm going to draw this 4 subinterval. This is how I'm going to draw it. Is this over or under?
It's over because it's concave down. No, wait,
Concave up.
Sorry.
Ethan, math practice on Wednesday. Show up on Wednesday. You have a good brain for it. Not a lot of people can figure that out. Wednesday.
I guess.
Show you next. See you next Wednesday. You enjoyed it.
We would.
All right, so 4 subinterval. So then you're gonna do 4 trapezoids. How do you do trapezoid? It's 1/2 base 1 plus base 2 times the height, but you're gonna do it 4 times. So I'm gonna do, so that's a number is really helpful. 1/2 base 1 is 1, base 2 is 2, right? And times the width, the height, which is 1/2, because here it's 1/2. Plus 1/2 times 2 plus 4 over 1/2. Wait, Kelly, how much time I have? Oh, I have 5 minutes. Why am I rushing? Plus 1/2, 4 plus 8 and 1/2. Plus 1/2 times 8 plus 6 times 1/2. First is, this part is the average of base. And this is height, which is the width of rectangle. So it's kind of makes sense because this is 1/2, this is 1/2, this is 1/2, and this 1/2 becomes the width, but it's the trapezoid for the height. So it's kind of confusing. So the easy way to calculate this, there was actually a trapezoid rule. It's going to be 1 over 2n, which is 4. And it's going to be 1 plus 2 plus 2 plus 4 plus 4 plus 8 plus 8 plus 16. This is 16.
Less tedious way to do it.
So this is 16 and this is 8. This is a 5, so it'll be 5 plus 8 plus 16, so it's 32, 40,
45.
45.
Be,
45 over 4.
11.25.
11.25, which is, what's the average of 7.5 and 15? 11.25. Good job. You are the first person to figure out that is the trapezoid rule. If you average the right end approximation and left end approximation, it's gonna be a trapezoid, so you don't need to do extra calculations. Ethan, Wednesday. I'll put you on the group chat.
I guess it makes sense because yeah.
You got offer.
Roast you one.
Roast D1. D1 Matthew.
He's adding that diversity.
He's white.
Yeah, it's that.
Huh?
Are you on the spectrum?
Oh, Matthew.
Oh dang! I can't jump.
Matthew is not a white person. Matthew Sheldon.
I can't.
There are too many white people. We need to recruit some different races. Chase got it. Chase got it. Chase got different ethnicity in him. He's got white blood and a Korean blood. Is it?
Hey, stop playing right now. Your mom's the whitest person I've ever met.
My brother is Blasian, bro. Y'all don't believe me? I'll show you.
I don't know. Show me like some dark Asian.
Where is
In this year, what are you?
I'll take a picture like
Huh?
me and
Are you Chinese?
Taiwanese, actually.
from Taiwanese? Oh, okay.
So you associate yourself with Asian.
he's
That
Blasian.
doesn't make
How
you
does
look
it
like-
exist?
Well, he's
Taiwan
not
doesn't
Blasian.
exist.
Taiwan.
According to China.
You call everyone
According-
else. You think Taiwan doesn't exist? What the crap are you talking about?
Taiwan's like Canada.
Oh, I didn't have my cheek.
That's like the most communist thing you could ever say.
No, I hate China. The only good thing from China.
Oh,
No. I hate China as a country. I don't hate the Chinese.
Like,
Okay, it's much more safe for the children because during the day, if they're out on the streets,